Okay, in this video, we're going to be running through the released Fall 2012 North Carolina Geometry Final Common Exam. This is not the Common Core Geometry, which we will cover later. All right, this problem here, they need to find the measure of angle NLM. That's this angle right here. We'll call it X degrees for right now. This is a right triangle. I know two of the sides, and I need to know one of the angles. This is a trig problem. I'm going to identify the sides involved. I always identify the hypotenuse first, and 700 is adjacent to our angle x. So adjacent and hypotenuse, this is a cosine problem. Cosine of x, we always feed cosine the angle, and it's going to spit out the adjacent side over the hypotenuse. To solve for x, we need to take the inverse cosine. And I'm going to have to get out my calculator to do that. Inverse cosine. I need to make sure I'm in degree mode. And I am. Okay. Second, cosine, 700 over 728. And the answer is 15.94. 15.9 degrees, that's a rope is attached to the top of a 25-foot pole. The pole is perpendicular to the ground. Ground, pole, perpendicular, and the rope, how far from the base of the pole must the rope be to make a 30-degree angle? All right, so obviously this is a triangle. More trig. Here's the rope. We're going to make a 30-degree angle with the ground. So 30 degrees is right here. Okay, 25-foot pole. How long does the rope, or how far from the base of the pole? Okay, so don't care about the length of the rope. How far from the base of the pole? Again, I'm going to call this x. Now, just like the first one, I've got two sides and an angle of a right triangle. I could use trig, but if that's 30, that's 90, this is 60. This is a 30, 60, 90. So I'm going to remember that the long leg, the one that I want to find, is equal to the short leg, which is 25, times the square root of 3. All right, again, we'll go to the calculator to approximate this. Oh, you don't want to see that. 25 square root of 3. Square root of 3. 43.3. Let's see. Okay. We've got a tablecloth placed over a table. How many square feet, this is area, hang below the tabletop? Okay, well, this is off the tabletop, so it's this, and this, and this. So this is a very strange shape. I don't have a formula for it, but I am going to take the area of the circle, the whole tablecloth, and I'm going to subtract the area of the table. The area of the circle is pi r squared. Ooh, I don't know the radius yet. And then I'm going to subtract. They said that the each side of the table is 4, so it's a square. 4 by 4 is 16. We've got to figure out the radius of this table. Well, the radius is right there, and that's going to be hard to find, but if you'll notice, I can find the diameter without too much trouble. This is a square, so that's 90 degrees. This is 4. So this is a 45, 45, 90 triangle because it's isosceles and right. You can either use the Pythagorean theorem to find the length of the diameter, or you can use the formula that the hypotenuse is equal to the leg, square root of 4, it's 4, times the square root of 2. Now, I could plug this into the radius, but it's not the radius, it's the diameter. So the radius is going to be half of that, which half of 4 is 2. So it's 2 square roots of 2 instead of 4. All right. So I actually plugged it in earlier, and I did it wrong. It's 2 instead of 4. Okay. And so the difference is 9.13. They said approximately, and 9 is the closest. All right, TR is the diameter of circle O and has a length of 16 feet. So the diameter is 16. What is the approximate area of the sector? Well, the area of the sector is n over 360. We're asking what part of the circle, what fraction of the circle, times the whole area, or the area of the whole circle, which is pi r squared. All right, n stands for the measure of our arc. We're talking about PQR. That's going to be the measure, well, this is 55 and this is 70. So it's 125 degrees over 360 times pi. And TR is the diameter. It's 16. The radius is 8. Squared. Again, to the calculator, 125 divided by 360 times pi r squared. Okay, about 69.8. Okay, rounded up to 70. If the dimensions of a rectangular prism, of one rectangle, are twice those of a smaller rectangular prism, what is the ratio of their volumes? Okay, the dimensions are twice as much. Okay, we did not have time to get to this section in the textbook, but you guys are perfectly capable of figuring this out. What I'm going to do is just pick an example. We've got two prisms, and one's dimensions are twice as big as the other. So I'm going to go with 1, 1, 1 for the other one. So obviously, if the dimensions of the next guy are twice as much, it's going to be 2, 2, 2. Okay, let's talk about the volumes. This guy's volume is 1 times 1 times 1. This guy's volume is 2 times 2 times 2. So if the dimensions are twice of those of the smaller, what is the ratio of their volumes? Clearly, it's 8 to 1. If a point is chosen at random on AG, what is the probability that the point will be on BE? Okay, so we're picking a point at random. This is probability. It's what we want to happen over what can happen. Okay, what is the probability that it will be on BE? Well, we can't talk about area now, but we can talk about length. BE is 6 long. Out of it can land on AG, well, A to G is 12. So the probability is 50%, or 1/2. If a point is chosen at random inside the rectangle, what is the probability that it's inside the triangle? So again, it's what we want to happen over what can happen. We want it to land in this area right here. That's a triangle. The area of the triangle is 1/2 times the base times the height. We're going to divide that by the area of the rectangle, which is 12 times 15. Be careful when you're plugging this in the calculator, particularly on the bottom, but you can go ahead and put parentheses around the top and the bottom. It's 9 over 180, which simplifies to 1 over 20. Calculator is perfectly capable of doing this. Okay, number 8, which statement is logically equivalent? I wasn't around. I hope you covered conditional statements and their converses and their inverses and their contrapositives. Hopefully you remember that the contrapositive is logically equivalent with the conditional statement. Contrapositive, if your original conditional statement is P implies Q, then the contrapositive is not Q implies not P. So if two angles are vertical angles, then they are congruent. It should be if two angles are not congruent, then they are not vertical. So we switch and negate. If two angles are not vertical, If two angles are congruent, If two angles are not vertical, If two angles are not congruent, they're not vertical. That's it right there. Okay, PQR is congruent to RQS. PQR is equal to 30. And RQT, the bottom one here, is 75. So let's get a different. So the big one here is 75. All right. Well, if this is congruent to that, then this one's 30. And if this is 30 and the whole thing is 75, well, this one has to be 75 minus 30, that leaves 45 degrees for SQT. Is that what they're asking about? Yes, they are. 45 degrees. Okay. They tell us these two segments are parallel, and they give us most of the coordinates, but you'll notice we don't know that one. So what is the value of y? Well, since the lines are parallel, we need our slopes to be the same. So I'm going to find the slope of our S. Okay, I'm going to do y2 minus y1. So that's negative 2 minus negative 6 over x2 minus x1. That's 0 minus negative 4. Okay, negative 2 minus negative 6 is 4. 0 minus negative 4 is 4. So its slope is 1. All right, now again, these lines are parallel, and so when I find the slope of PQ, I should also get 1. Let's find the slope of PQ. I've got x2, y2 over here, or x1, y1 over here. y2 minus y1 equals x2 minus x1. All right, so y minus 0 is y. 0 minus negative 4 is 4. So I need this slope to equal 1 because it's parallel to the other one. Well, now I just solve for y by multiplying each side by 4. So y equals 4. You could probably draw that, and you might get a good idea as well. All right, in the drawing below, QR is equal to 3x plus 6. This is length, not angles. And ST is 12x minus 6. Okay, well, this is the mid-segment of a triangle. And hopefully you remember that it's basically half the length of that. You can clearly see that they're not equal. So when in doubt, just try to think your way through it. So we'll say that this is about half as long. It's actually exactly half as long as the other side. I'm going to multiply by 2, or I'll distribute this 1/2 over here. Half of 12x is 6x, half of 6 is 3. Now I'm going to subtract 3x from both sides. I'm going to add 3 to both sides, divide by 3. What is the length of ST? They want us to put 3. They figured out x for us, but that's obviously not the answer. We want to find ST. So I'm going to plug it in. It's going to be 12 times 3 minus 6. 36 minus 6 is 30. In the diagram below, what's the value of x? Okay, they want you to use the exterior angle theorem. You don't even have to remember it, though. This is an isosceles triangle. That means these two base angles are congruent. If this is 20, that leaves 160 degrees. So each one of these angles is 80. Now, if you'll notice, this angle and this angle are a linear pair, so this is 100 degrees. I've got another isosceles triangle here. That means these two angles are congruent to each other. They have to both be 40. And then 40 and x are supplementary, so 180 minus 40 is 140. In the figure below, we have a rectangle, and SMN is 65. SMN, that's this angle, it's 65 degrees. Okay, because there's a lot of ways to do this, what you need to remember is that a rectangle has 4 right angles, and the diagonals are congruent, as well as bisecting each other. So I can say this angle here is 25 degrees because these two add to 90. And even if you weren't familiar with the rectangle, it's pretty clear that this guy and this guy are equal to each other. The reason I know that is because the diagonals are the same length and they're each cut in half. That means it's an isosceles triangle, so this guy's 25 as well, and that means this angle is 65. Okay, again, there's more than one way to solve that problem. My bad. It's not 65, it's 25. I put the right answer the first time. Okay. All right, they give us all this information. What's the length of EH? Well, first of all, let's see what we've got here. The top and the bottom are parallel, and the left and the right are parallel. That means it's a parallelogram. We know about parallelograms that opposite sides are congruent. Yes. Okay, so let's see. Let's fill these in. FG is 2x plus 4. EG is 3x plus 9, and FH is 7x minus 3. Okay, I'm tempted to say the diagonals are congruent, but all I've proven so far is that it's a parallelogram. Well, we've got right angles here and here, and we know opposite angles are congruent in a parallelogram. This is a rectangle, so our diagonals are actually congruent. The diagonals are 3x plus 9 and 7x minus 3. Subtract 3x from both sides, and then add 3 to both sides. So x equals 3. We need to find EH. They didn't tell us EH, but we know that FG is equal to EH. FG is 2 times 3, 6 plus 4, that's 10. So is this, we're done. The measure of interior angle of a regular polygon is 156 degrees. 156 degrees. How many sides does the polygon have? Okay, we've done problems like this before. It's a regular polygon. So what we need to figure out is there's 2 ways to do this. We can use the sum of the interior angles. It's 180 times n minus 2. We don't know how many sides this has, so we're just going to leave it as n. The other way to figure this out is, well, I've got n angles, and they're all 156 degrees. So I can solve it this way. 180n minus 360 equals 156n. Subtract 180n from both sides. Leaves you with 24n. Divide by 24, or negative 24n. Divide by negative 24, and you get 15. The other way to do it would be to recognize that the exterior angle is 24 degrees. And since all the exterior angles add up to 360, you can just divide 24 degrees by that, and you get 15 sides. Either way, obviously this way is shorter. Number 16, which regular polygon has interior angles that are 3 times as large as the exterior angles? Okay, well again, I'm going to draw, this is my interior angle. This is the exterior angle. So I don't know how big the angles are, but I know that the exterior angle is smaller, so I'm going to say it's x degrees, and the interior is 3 times that, so it's 3x degrees. Okay. This angle plus this angle is 4x, and they're a linear pair, so they equal 180. So x equals 45 degrees. So this is 45 degrees on the exterior angle and 135 degrees on the interior. How many sides does this have? Well, again, what we did on the last page, we said 360 degrees exterior every time. And if one of those is 45, I just divide, and I find that the number of sides is 8. The number of angles is 8, and therefore this is an octagon. Okay, we've got a regular polygon. Which statement is used to prove that PQR, let's highlight this. PQR, that's too large, is congruent to PTS. Okay, I want to prove these guys are congruent. I've got to find sides are the same, and I've got to find angles are the same. All right, we're going to use side, angle, side. Well, let's see what we've got going here. I guess we could just look at our options. Angle T is bisected. I look at angle T. It's not bisected. That's clearly wrong. Angle S is bisected. First of all, it might be bisected, but I'm not really sure. It doesn't look like it. I think that's wrong. Regular polygons have diagonals that are congruent to their sides. That's a diagonal. That's a side. They're clearly not congruent. I don't know what. So the answer by elimination is D. I want to show you why this is true. They have congruent angles and congruent sides. Yeah, I know that PQ and PT are the same because it's a regular polygon. All the sides are the same. So that gives me those. I also know all the angles are the same. So I can use side, angle, side to prove they're congruent. A regular hexagon tile has a perimeter of 36 inches and measures 3x inches across. A smaller tile is a regular hexagon that measures x inches across. What's the perimeter of the smaller tile? Okay, well, if the perimeter of this is 36 inches, each side is 6. And again, we didn't cover this, but it's a fairly obvious. Hopefully, it'll ring true with you. If this is 3x and this is x, that means every linear measure over here is 3 times longer than every linear measure over here. And therefore, if this is 6, this has to be 2. It's kind of a scale factor thing. The scale factor is 1/3. 1/3 of 6 is 2. So what's the perimeter? Oh, it's 6 times 2, which is 12. S and T are 2 points on a sphere with center R. So let's draw a sphere with center R. And the radius of the sphere is 4. What statement must be true? Okay, they're talking about ST. Oh, SR is right here. Well, if S is on the outside of the sphere, R is in the center, so SR is 4. That's really the same statement as this. So they're probably both wrong. We need to figure out how long ST can be. Well, if S and T are right beside each other, and I'm talking right beside each other, they're just a little bit greater than 0. So that explains this part. But how far apart can we get S and T? Well, let's say we have S on this side of the circle, or sphere, and T way over here. To get there, we have to go through the radius, and that part's 4, and that part's 4, so they'd be exactly 8 apart. So exactly 8. So that's a possibility. So the answer is D. So we've got a room here, and we're sending a beam, infrared beam, from one corner to the opposite corner. because this is a rectangular prism, all the angles are 90 degrees. So we need to figure out this beam. And let's see if we can go straight down from there and across. I've got a right triangle. Let's see. And I know the height of this triangle is the height of the room up here. So that's 8. And then there's the beam. And I don't know this side right here. I don't know what X is. But, before giving up, I'm going to notice that this X is a part of another right triangle, which is right here. Okay, and let's see, one of the sides is 12, X is the hypotenuse, and this other side is 9. So let's use the Pythagorean theorem to find X. It's 9 squared plus 12 squared equals X squared. And this is actually a 3, 4, 5 triangle, or 9, 12, 15. So X is 15. You could use the Pythagorean theorem to find that. And now I can actually plug it in for the other one. I'm going to have 8 squared plus 15 squared equals the beam squared, which is, I'll just call it B. And you can use the Pythagorean theorem to find that B is exactly 17. 17. Okay, the cylinder shown below has a radius of 10 centimeters and a height of 15. A wedge of the cylinder is formed by a central angle measuring 18 degrees. What percent of the volume of the cylinder is the volume of the wedge? Okay, we could find the volume of each and calculate the percent. We could say volume of the cylinder, or we could volume of the wedge divided by the volume of the cylinder. But that's too much work. If you look at the end, it's just a circle with a wedge cut out, the percent's going to be exactly the same. So the percent of the circle and the wedge here is going to be exactly the same. Now, we can just look at the degrees. The degree of the wedge is 18 degrees, and the degree of the whole circle, or the whole cylinder, if you will, is 360. And put that in your calculator, it should be 0.05. Again, you could find the volume separately, but it's just more work. Basically, you multiply their areas by the height to get the volume. All right, so we have a translation here, or a transformation? Yes. These are transformations. We just need to see what happens. Well, let's see what happens to P. I'm just going to look at it. I have to go, it looks like 1, 2, 3 to the left, and then 1, 2, 3, 4, 5, 6, 7 down. So that's left 3 and down 7. So X should be minus 3, and Y should be minus 7. Ding, that was easy. Okay, P is transformed using this rule, so there's a translation, and the image is rotated clockwise, not counterclockwise, resulting in point P double prime. What are the coordinates of P double prime? Okay, well, first of all, we need to do the first translation. So I'm going to start here, and then I'm going to subtract 3 from the X. Well, negative 3 minus 3 is negative 6. And then I'm going to add 1 to the Y. Negative 1 plus 1 is 0. And now I'm going to rotate this clockwise. Okay, well, I need to get a picture of this. Negative 6, 0 is right here. Okay? And if I'm rotating this 90 degrees clockwise, it's going to go right here. Okay? And you can probably guess that. But remember, when we rotate 90 degrees, we're going to switch the X and the Y. And then you're going to just look at where it ends up, usually at the quadrant, but this time it's on the axis. And that's going to tell you what the signs are. Well, I know that 6 is positive, and 0 doesn't have a positive or negative. So there's our answer. That's P double prime. Quadrilateral will be rotated 180 degrees about the origin. Which rule will describe the transformation? Okay, 180 degrees. So let's just do two 90-degree rotations. And I will pick, for my purposes, I don't want the ones on the axis because the zeros don't tell you very much. I'm going to start with this guy, negative 1, positive 3. Okay, I'm going to rotate that 90 degrees clockwise, counterclockwise, and then 90 degrees counterclockwise again, and that should tell us, that should give us an idea. So remember when we rotate 90 degrees, we're going to switch the 3 and the 1. So down here, it's going to be, instead of 1, 3, it's going to be 3, 1. And I'm going to be in this quadrant. Everybody in here is negative, so let's do that. Negative, negative. Negative 3, negative 1. So this is 90 degrees into our trip, if you will. And then we're going to go 90 more degrees. Well, when I move over here, I'm going to switch the 1 and the 3. And this quadrant's going to tell me the signs. I have to go positive, negative. So 1, -3. That's what happens when you rotate it 180 degrees. You might remember it's also the same thing as reflecting it over the origin. In any case, I started with a -1, I ended up with a +1. I start with, start with an x, I end up with a -x, a -x. I started with a positive y, I end up with a -y, so I need a -y there. So the answer is D. All right, triangle has these vertices. If it's dilated by a factor of 1/2, what is x prime? Well, x is the new, where is x going to be? Because we're doing this about I assume we're doing about the origin, we're just going to multiply 6 by 1/2 and multiply 2 by 1/2. That might be the easiest problem on the test.